The following Karnaugh map algorithm that we're going to cover gives a minimal representation of a Boolean expression. And remember that minimal representations don't need to be unique. So the first step is to circle the isolated ones. So these are the ones that are not adjacent to any other ones. So as we can see, all of these ones have adjacent ones. So even these two are adjacent. So in the next step, we find all the uncircled ones that are only in one block of two. So here we find this one over here that we have not yet circled, and that's only adjacent to this one over here. So these are in a block of two, and we'll circle them. Now in step 3, we find the uncircled ones that are only in one block of 4. So this one over here is only in a block of 4. So we circle this block of 4. So this one over here is in a block of 6. So we go to the next step, where we find the uncircled ones only in one block of 8. So here we don't have any ones in a block of 8. So we go to the next step, where we find the uncircled ones and circle the largest possible block to which they belong. So that could be a block of 2, 4, or 8 ones. So in this step, we choose such that we have a minimum number of circles. So as we can see, this one over here belongs to a group of 4, and this is our other uncircled one that also belongs to a group of 4. So either choice is going to give us a minimum number of circles. So we'll just take this block of 4 over here. And now we're left with no uncircled ones, so we're done. So the group of 4 on the left hand side gives us W, Y. So remember that W and Y here is common between these 4 ones. And the next block of 4 gives us Y and the complement of Z. And finally, for the remaining 2 ones, we have W bar, X bar being common to these 2 ones, and Z is also common to these 2 ones. So this here is our minimal representation of this Boolean expression. And I encourage you to actually expand these out using Boolean algebra, and you'll see that they're equivalent.